Alright, this is a reflection problem, and it's very similar to a problem that gives a lot of people a lot of trouble in this class. So that's why I want to do something very similar. Okay, first off, we have a light beam coming in at 20 degrees above the normal. It's then going to reflect off this mirror, which is not on the ground. It's kind of tilted at 5 degrees, and it's going to bounce off it and hit this wall. Okay, that's 4 meters away. Now the question is, how high where the beam strikes, how much would it change if I changed this mirror to 10 degrees instead of 5 degrees off the horizontal? So we got to basically do the calculation twice, one with the 5 degree mirror, one with the 10 degree mirror. So let's take a peek at it. With the 5 degree mirror, okay? Well, let's talk about law of reflection real quickly. Law of reflection says that you're going to bounce off at the same angle that you hit at. Okay? So this is coming in, and you might think, oh, it's coming in at 20 degrees. Yes, if it was hitting something flat. But remember that we're not talking about hitting something flat. We're hitting something that's already diagonally across the ground. So we have to consider what this angle is. Okay? The angle of incidence. And in this case, it's not going to be 70, which would be, if it was 90 minus 20, it would be 70. It's not going to be. It's going to be 65. And the reason is that we've got this 20 degrees, we also have another 5 degrees there. Alright, so we have 65. That means it's also going to come off at 65. And I see it's not drawn to scale here. But this is going to be 65 degrees. Okay? And what that means is that this angle here is going to be 90 minus 65, or 25, plus an additional 5. Okay? And the reason is that, remember we got 5 degrees, another 25 degrees, and then the 60, so and those two together make 30. So, to get this little triangle, we have a triangle 4 meters long and 30 degrees. So how do we figure out this height right here? Well, we say we want x over 4 meters. Okay. And that's equal to tangent of 30 degrees. Now, you might say, Aiden, what's tangent of 30 degrees? And off the top of the head, Aiden doesn't know because Aiden did it for sine of 30 degrees, not tangent. So give me 1 second, and then I will tangent this. And that comes out to be the height of 5 degrees is 2.309. Yeah, meters. There we go. Awesome. All right, so now let's consider. We've moved it 10 degrees. Okay? Let's go back to this draw. I'm going to erase as much as I can here. Okay? So now the mirror is at 10 degrees. Reflection's coming in. This is still 20 degrees from the horizontal. Now that means that this is right here is 10 degrees, which means that this is only 60 degrees. The angle of incidence is only 60 degrees, which means the angle of reflection is also going to be 60 degrees, which means that this is 30 degrees here, 90 minus 60, and this is 10 degrees, which means that our total angle is 40 degrees. Okay? So at the 10 degree spot, we have our equation being x over 4 meters is equal to tangent of 40 degrees. And I'll have to make the same little, fix here. Oopsie. 40 degrees times 4. And that's going to give us a height of 3.36 meters. So by angling that just a little bit, by another 5 degrees, we've gained 1.05 meters of height. Okay? Awesome.